My name is Anna Nadolna, and I'm a member of 40th Polish Polar Expedition to Spitsbergen on Svalbard. I work here as a meteorologist for the following year, so since July this year to next July. But as for my education, I'm a geographer and with a specialization in hydrology, which is why today I would like to talk a little bit about water resources of the Arctic, which is in a way my home now. So let's begin. Actually, because we are going to talk about water resources, I would like to start with a question for you. What is the largest reservoir of fresh water on Earth? How do you think? Let's say I will give you 1 or 2 minutes and you can write your answers in the chat box. Okay, so the proper answer is the Antarctic Ice Sheet. So those of you who write snow, ice, then that's more or less the proper answer. Groundwater as and or clouds or rivers paradoxically are not the biggest sources of fresh water on Earth. We will talk about this today. So the largest reservoir of fresh water on Earth is Antarctic Ice Sheet. As you can see on the slide, Antarctic Ice Sheet is one of the two polar ice caps of the Earth. It covers around 98% of whole Antarctic continent and is the largest single mass of ice on our planet. It has a very big area because over 14 billions of square kilometers, and as you can see on the picture, it's bigger than Europe, and it contains really a lot of ice, over 26 million cubic kilometers of ice. So that's a lot of water in a solid form. And it is estimated that this ice located on the Antarctic ice sheet is more or less 60% of Earth's fresh water. And if we would melt all this ice, the sea would rise by nearly 60 meters. And if it's hard for you to imagine how much can be 60 meters of water, then this slide should be helpful. We've got here some famous buildings from Europe and not only. And if we would melt this ice from the Antarctic, well, those buildings, well, some of them actually would be underwater, like Colosseum or 1/3 of the Eiffel Tower, and even almost whole Statue of Liberty. So 58 meters of water, it's really quite a lot. But if we want to talk about water resources, we need to know some basic terms, because water resources is generally hydrosphere. What is it? It's a discontinuous layer of water at or near Earth's surface, and it includes all liquid and frozen surface waters, groundwater held in soil and rock, and atmospheric water vapor. Well, this might sound a little bit complicated, but we can say in general that hydrosphere is all water found on, under, and over the surface of the Earth. So it includes water in all three forms, so solids in a solid form, like ice or snow, in a liquid form, what we have in rivers, lakes, oceans, and in gas form, so in water in the atmosphere, in clouds, and so on. And the science that is concerned with hydrosphere is called hydrology, and people who work in hydrology are hydrologists, of course. I am a hydrologist. And hydrology in general is a scientific discipline concerned with the waters of the Earth, including their occurrence, distribution, and circulation via the hydrologic cycle, and interactions with living things. So it covers quite a lot of topics. Hydrology also deals with the chemical and physical properties of water in all its phases. Well, so in general, it's hydrology is an environmental science that deals with the study and description of hydrosphere, and the main subject of research is the circulation of water in the environment. So the water cycle that you can see on the picture, where water cycle or hydrological cycle is a continuous process by which water is purified by evaporation, and then it is transported from the Earth's surface, or including the oceans, to the atmosphere and back to the land and oceans. And this is a constant movement of water in our environment. Okay, so we can say that hydrosphere is actually all water that is found on Earth. And but what does this actually mean? Is it a lot? How much of this water there actually is? Well, as you can see on the picture on the slide, of around 70% of Earth is covered by water, and the hydrosphere is estimated to nearly 1.5 billions of cubic kilometers, which is really a lot of water. But as you can see on the picture, a vast majority of this water, nearly 98%, are oceans. So it's a salt water, something that we can't really use, can't drink, and fresh water, which is water that we can drink, that we use in our everyday life, it's only not even 3% of that. And from this 2.5%, most freshwater is actually in ice caps and glaciers. Nearly 80% of all of Earth freshwater are ice caps and glaciers, and another 20% is groundwater. So the water that we may think of in the first place, like rivers and lakes and maybe some water in the soil, constitutes of very, very small amount, not even half of the percent of water resources. But those were some percentages, some proportions. Here you've got some real numbers. Of course, you have to remember that these are only estimates, because we can't precisely measure how much water is in lakes or in the atmosphere or in groundwater. So these are the estimates that are done by hydrologists, and depending on the source or the author, these numbers might be a little bit different. But the general rule is it's the same. So most of the fresh water, vast majority, is in ice caps, glaciers, snow, and permafrost, and 1/3 is in the groundwater. So that is worth remembering. So how much water is in the polar areas, which is our topic today? Well, as you can see on the table, most of the water is in the polar areas is located in Antarctic and Greenland, as those are two biggest parts of land in polar areas. And how much is the water there? Well, it's around 24 millions of cubic kilometers, which is not even 2% of water in our hydrosphere. And numbers are not the best thing to look at, so here is a map that should make this more clear to you. Here you can see the glaciated areas in on our planet, and as you can see, most of them are concentrated in the south and in the north in the polar regions. So also, as you can see on the graph below, most of the glaciers, well, the vast majority is located in those areas. Of course, we've kept also some glaciers on other continents, like in Asia, where there are Himalayas. But this is a very, very small amount of ice and snow. Okay, so let's focus on the Arctic. How do you think? What's the source of drinking water in the Arctic? Is it difficult for people to get drinking water there? We can generally say that getting water in the polar regions, in the Arctic, is a challenge for people who live here, for the engineers also. And why is that? I will tell you in a minute. So, water resources of the Arctic. Obviously, as you can see, water in the Arctic is estimated to be around 2 million of cubic kilometers. So, in comparison to all polar regions, that's not very much. But as we already know, most of the water is, of course, in the Antarctic. As for the Arctic, most, I think, over 90 or even 95% of the water resources is concentrated on Greenland, as it is the biggest part of land in the Arctic. And Spitsbergen, which is a small piece of Arctic that I would like to concentrate today. Although it's covered, 60% of it's covered by glaciers, ice and snow. It's only very, very small part of those resources. So let's take a look at the practical side, how people deal with drinking water in the Arctic. When I asked you about how people cope with that issue in those areas, you wrote that it is difficult. You have to heat it first, or even boil it and clear it, and that's all true in a way. But in case of Longyearbyen, it's a town, the biggest town on Svalbard. Actually, it's the capital of Svalbard, located on Spitsbergen. I don't know if you know, but it's a northernmost settlement with a permanent population of over 1,000 people, where average temperatures are from -16 in winter to +6 in the summer, and there is not much of rain and snow during the year. And currently over 2,000 people live there, and as you may think, all of those people need water for everyday life. Just a second. And yes, so all those people need water, but it would be hard to for them if all of them would have to go and get the snow and heat it, boil it, and so on. So organizing access to water for that number of people, it's quite a challenge for the engineers. And so how it is done? Well, in let's say normal classic house in let's say Europe or in America, we get water from the groundwater layer. So we have a pump, and we pump this water from under the ground, and that's it. We've got clean, nice water in our home. Well, in case of Arctic, this is not going to work. Why is that? That's because we've got a permafrost here. Permafrost, it's in a shortest definition, a permanently frozen ground. It is soil, rock, or organic material that remains at 0 degrees or for at least two consecutive years. So we cannot use the water that is underground because it's simply frozen to ice. So there is no way to use it. And in case of Longyearbyen, the resolution is quite simple. City takes the water from the anthropogenic reservoir called Isdammen. It's a man-made reservoir located east of the settlement. It's not very big, nor it's not very deep because it has the maximum depth of 5 meters. So as you can imagine, it's not very much. But still, that's enough for this small town to work properly. Of course, in a summertime, there is no problem with pumping the water from that reservoir, as there is a lot of water from melting of ice, snow, and from the glacier. What about winter? Well, in winter, a large part of the water in the reservoir is obviously frozen to ice, but this ice is not very thick because it's usually less than 1.5 meters. So we still have some water under this ice that we can use. We can pump it. And as you can see on the picture, here those pipes that looks quite funny. Those are the water pipes that are transporting water from this Isdammen reservoir to the city. Unlike the other water supply nets in Europe or in other countries, pipes are not in the ground but above it, and they are insulated and equipped with special heating cables so that the water wouldn't freeze inside, and it could be still transported to the city and to homes. So this is how it has to be done so that people would have water. Obviously, there are also issues like water quality because, well, there can be some pollutants in the ice or snow. So when people are planning where to take the water from, they have to take that into consideration and monitor places like Isdammen Reservoir, whether this water is of good quality so that they could drink it. And what about the place where I'm staying at the moment? So the Polish Polaris Station. As you may know, we are far from Longyearbyen. We are around 140 kilometers south of this city. Our station is, well, it is located actually in the middle of nowhere. There is no civilization near us. There is no electricity line, no water line. So we have to make things our own, and that includes well, water. How is it done? Well, in the summer, it's quite easy. We've got a small reservoir near our station that you can see on this photo. We call this reservoir a lake, but obviously this is not a lake. Actually, we could say it's a small pond. It's very small and very shallow. I think it's It has the depth of around meter and a half maximum, and it's filled with water from melting of ice and snow. And we have installed a water pump inside, and we pump the water to our station. So that sounds easy and nice. But sometimes, when the summer is dry, there is not much rain, and a lot of people is in the station because during the summertime there is a lot of scientists are coming here for their research, so they use a lot of water. And sometimes there is a situation that this lake is dry, and expedition members are quite thrilled, like, "Oh my God, there is no water. What shall we do now?" I can tell you, relax. That's not the worst thing that can happen here, because although there is no water in the lake, we still have some ice. Ice that it is thrown by the sea or on our shore, because near our station there is Hornsund Glacier, which is calving, and a lot of that ice often ends up on our beach. So we can go and collect that ice and transport it to our station, where we put it in a special water tank. As you can see on this photo, we have to do it by our own hands because there is no other way. We have to put that small ice blocks into a special water tank that you can see on those pictures. These tanks have some heating inside so that the snow or ice could melt faster. And, well, yes, the ice is melting and we have water. Obviously, this method is a little bit tiring for a longer period of time, but still, it's a solution. Things look quite different in winter because in winter time, obviously, we cannot use our lake because it's frozen, but we have some snow around our station. And although there are only 10 people during the winter time here on the station, there is 10 of us here, but we still use, well, we use quite a lot of water, even though we try to save as much as we can. So, if we want to have a shower, we have to go every day outside and load the tank with the snow. So today we are going to do that after the dinner, and that's our everyday life now in the winter time. So every day we have to go out and load the tank with the snow. Quite tiring, but um, yes. But we can imagine a situation on our station that what if our lake will be dry because there is a lot of people, they use all the water, there is no rain, there is no snow, there is no ice on the shore because sometimes simply there is no ice on the shore. So what then? We are we don't have any source of water. Well, obviously in that kind of situation there is no shower for anyone, and definitely you cannot use the washing machine. And still, we have some supplies of bottled bottled water. So on the station we have supplies of bottled water, mineral water, and we can use that for cooking, for some most important things. And with that, we could, well, survive for some time. So that's also a solution here. Okay, but it's we are talking about water resources and how nice it is to have a warm shower in the Arctic. But what is also important, and I think not a lot of people is actually aware of that, is what happens with all this water after we use it. Because as I said, it's great. It is great to have a shower in the Arctic or in a station or anywhere else on the world. But this water disappears somewhere, and it usually at the other end of the pipe. It doesn't look as good as in our shower. And yes, we use it and it disappears. So what happens with the sewage? Because this is what we are talking about at this moment. Sewage, or called also a wastewater, is all that dirty water that comes from our toilets, our washing machines, our dishwashers, and so on. It can contain a lot of detergents, toilet paper, food waste, excrements, many pollutants in general, such as bacteria, nutrients, toxins, or microscopic plastic fibers. And all these waters go somewhere. Well, it's in when we live in a city, it usually goes to the sewage system, sewage network, to the canals, and then to some sewage treatment plant where it's cleaned and can go back to the environment. But what happens with the sewage in the Arctic? Well, for many years, nothing happened with the sewage. By nothing, I mean that all the sewage was going strictly to the fjords and to the sea. Currently, there are two sewage treatment plants on Spitsbergen, and I'm proud to say that the first sewage treatment plant was built on our station. So we were the first one that started to clean the sewage before discharging it into the fjord. A few years later, a sewage treatment plant was built in the north, in Ny-Ålesund, but that is also a scientific settlement where around 200 people live. So it's a small settlement. And what about the Longyearbyen? Well, over 2,000 people, and believe me, there is no sewage treatment plant there. So all the sewage, all this wastewater goes directly into the fjord. And this is a very important issue in environments like Arctic, which are very fragile and sensitive, because sewage reaching seas and oceans um, can contain some substances that can harm those ecosystems, or even pose a significant public health threat. Of course, and so far, people say that nothing is happening in the fjord near Longyearbyen, but in a few years, in the future, that might change if still the sewage will be pumped into this ecosystem. But I wouldn't like to finish in such a negative way. I would like to finish this lesson with something positive and a small curiosity, actually. So the Polar Code. I don't know if you have heard about the Polar Code. It is an international framework to protect the polar regions from maritime risks. Because when we talk about water resources, water in general, and sewage and pollutants, well, ships that are operating in the open waters of the polar regions, are also discharging a lot of sewage and garbage and other pollutants. And because trends and forecasts indicate that this polar shipping will grow and divers, diversify over the coming years. That is why the Polar Code was invented. It started to work. It entered into force on the 1st of January this year. So it's a brand new thing, and it has a lot of regulations regarding the safety of life at sea and for the prevention of pollution from ships in polar regions. So in both in the Arctic and the Antarctic waters. What you can see on this slide is a part regarding the protection of the environment. So this Polar Code has a lot of regulations regarding what ships can do and what ships cannot do. Most of those regulations say that ships cannot discharge any sewage into those waters or oil or any garbage, plastics, food waste. That's all prohibited. Also, in those regulations, you can find information that ships have to have some special equipment on board so that they could have all those contaminant substances on board. And I think that's a good information and a good solution, and I hope this will help the water resources of the Arctic to be clean and nice for as long as it is possible. And with that, actually, I wanted to end.